A War Job Thought Impossible, read by A. Humble Collector. A War Job Thought Impossible by Wesley W. Stout, Chrysler Corporation, Detroit, Michigan, 1945. The delivery of the 5,500th Sperry Gyrocompass, made by Chrysler Corporation, Rear Admiral E.L. Cochrane, Chief of the Bureau of Ships, United States Navy, wrote, will mark the completion of one of industry's war contracts originally considered impossible. Copyright Chrysler Corporation, 1945, printed in USA. Forward. Our business is principally the making of passenger cars and trucks. In the crisis of war, we took on, among many weapons and munitions, the making of this complex precision instrument, the Sperry Gyrocompass. We did so in the belief that the principles of engineered production, developed during years of peacetime manufacturing, could be applied to the making of this intricate device, so unlike anything in our past experience. The story told in the following pages speaks for itself. The compass, in design and engineering, is wholly the creation of the Sperry Gyroscope Company, to whom all credit for the magic of its performance belongs. Without the enthusiastic support of the Navy personnel assigned to this contract, and the cooperation of Sperry, Chrysler Corporation could not quickly have accomplished the first quantity production of this sensitive and vitally important mechanism. K.T. Keller, President. The other day, February 1945, Chrysler completed one of its war jobs. This was the making of 5,500 gyrocompasses for the Navy. The contract was a minor one dollar-wise, compared with tanks or super bomber engines, though as much as the corporation earned in such recent years as 1938 and 1939, the product will never kill an enemy, yet it is as vital to the war as a Bofors anti-aircraft gun or a tank. A gyrocompass is an extremely sensitive and exact mechanism, though not a little one. This model, with accessories, weighed upwards of 1,300 pounds. In the past, they were made a few at a time and partly by hand, by workmen of highly specialized skills. The Chrysler Corporation made them by engineered production methods, that is, speedily and in large numbers, using workers of no or ordinary skills who never had seen a gyrocompass until then. No compass ever was returned to the corporation as defective. In order to manufacture a precision instrument with ordinary labor, management broke the compass and its machining down into simple components, and operations easily taught a novice, so engineered the tooling that the accuracy was transferred from the mechanic to the machine tool. Chrysler built these compasses for 55% of the originally estimated cost. It took the contract at a figure set by the Navy, which had been buying compasses for many years, but now needed many more than existing facilities and trained working force could produce. The overall cost of 5,500 compasses, including spares and ordered extra equipment, under the estimate fixed in the first contract, would have been $42,689,000. The actual cost to the government was approximately $23,479,000, a saving of $19,210,000 to the taxpayers. When the 5,500th compass came off the assembly line February 9, 1945, the flagship signaled, "Well done," the Navy accolade. The completion of this compass, Rear Admiral E.L. Cochrane, Chief of the Bureau of Ships, wrote the corporation, will mark the completion of one of industry's war contracts originally considered impossible. That is, the manufacture of an intricate, delicate gyrocompass by other than a manufacturer especially trained and skilled in the art. A recital of all the important and interesting facts of this achievement would take volumes. It is, however, of particular interest to note that it was on February 5th, 1942, that two representatives of the Bureau first approached Dodge with a request that they consider the manufacture of gyrocompasses. Including that day, and until this 9th day of February, 1945, which marks the completion of the 5,500th compass, Dodge averaged 6 compasses every day, and this average could have been greater had the Navy's demands required an increase. The performance of the Dodge-manufactured Sperry compasses is already an enviable one. They have seen service in every theater of operation on large landing craft and auxiliary ships so vital to the successful operation of any fleet. The Bureau wishes to take this opportunity to extend to the Chrysler Corporation, and especially the Dodge Division, and all the personnel intimately connected with this contract, its appreciation for their splendid effort and achievement, and to say, well done. The Sperry Gyroscope Company told Chrysler at the outset that it would do well to produce one of these complex instruments in 18 months. When such a compass had been delivered to the Navy and was already in service less than 6 months after Chrysler was authorized to begin work, a Navy commander of the Gyrocompass section of the Bureau of Ships predicted that the corporation would not reach the then desired mark of 4 compasses a day before August 1943. Wrong again. Chrysler was making 6 a day by the first week of 1943, reached 8 daily in March 1943. Ships still must steer by compass despite other aids to navigation, old and new. Until recent years, the compass was a magnetized needle. Few of man's tools had changed so little in centuries. It was the same needle with the same failings which Columbus had followed to a new world, and even less dependable in modern steel ships than it was in his wooden caravels. Yet until the late Dr. Elmer A. Sperry invented the gyroscopic compass around 1910, there was no other kind. When accurate, the magnetized needle does not index true north, and it seldom is accurate. It is deflected by the metals of the ship, by the knife in the pocket of the helmsman, by magnetic disturbances in the air such as cause the static in your radio, and by ore deposits in nearby land. There are waters and times when it is worse than useless. If you ever have spun a top and rolled a hoop, you can understand how a gyroscope works. The top stands upright while it spins, contrary to the law of gravity, its spinning force being greater than gravitational pull. If a boy picks up a spinning top in the palm of his hand and tilts his palm back and forth, the top goes on spinning erectly, ignoring the shifting of its base. This escape from the dictatorship of gravity is called gyroscopic inertia, and is true of all spinning things, though not visible in all. The Earth itself is a mammoth gyroscope. If it did not revolve like a top with its polar axis fairly constant, life could not exist here, due to the rapid and extreme changes from heat to cold. Man long has known about gyroscopic inertia, but had not put it to practical use. A gyrocompass harnesses this freak of nature. The heart of such a compass is a heavy, solid bronze wheel, called a rotor, which, enclosed in a squirrel cage motor, spins much faster than any top. Suspended from above, the rotor is free to turn on all three of its axes. Put another way, only one point, the geometrical center of its supporting system, is a fixed position, the wheel being free to turn in any direction around this point. This means that when a ship rolls and pitches, the gyro holds its own plane of rotation, unchanged by any motion of the ship. Build a gyroscope large enough, and it will prevent the ship itself from rolling with the waves. But this is not all. The rotor ignores the Earth's rotation just as it does the ship's tossing. Its plane of rotation does not shift as the Earth turns. In this sense, it is a little sun, cockily operating in its own solar system. So far, this is no help toward finding the north. An ordinary compass needle is pulled toward north by the attraction of the magnetic pole. North is an earthly direction, and the gyro has declared its independence of the Earth. There are no directions in space where it spins, so of itself it can indicate no direction. As it refuses to follow the Earth's axis of rotation, its own rotational axis must be changing constantly in relation to any given point on this Earth, such as the North Pole. Here, Dr. Sperry introduced a second physical phenomenon, another freak of nature which scientists call precession. When a boy wants to turn his rolling hoop, he taps it with a stick, but not at the front or back as it would be natural to suppose. Though he does not know why, he puts the pressure on the top of the hoop as if he intended to tip the hoop over. Due to its rolling gyroscopic energy, it resists the stick's pressure and turns away at right angles. By this law, any force applied to either the horizontal or vertical axis of the gyro rotor is felt 90 degrees away. Apply pressure to the horizontal axis, and the gyroscope turns, or precesses, on its vertical axis. Apply the force to the vertical axis, and it turns on its horizontal axis. A frame supporting 4 cups of mercury, and called a ballistic, does for the rotor what the boy's stick does to the hoop. Mercury is a very heavy, liquid metal, and so is very sensitive to gravity. As the Earth turns from west to east, one side of the ballistic tends to rise, the other to drop. The mercury feeds through connecting tubes from the high to the low side to restore the level. In doing this, Dr. Sperry made it exert this precessive force. The rest is automatic. As the Earth always revolves from west to east, and as precession always is felt 90 degrees away from the point of application, then the gyro spinning axis is forced to right angles from west to east. This right angle is south-north. While the Earth goes on turning and the mercury column goes on compensating, the mercury constantly kicks the rotor back on the south-north meridian. A compass card or azimuth ring, with its zero graduation aligned with the rotating axis of the gyro, then always will register true north. Being deflected by no forces, in or exterior to the ship, a gyrocompass may be located anywhere, though preferably below decks at the vessel's center of gravity, with repeater compasses on the bridge, in the captain's cabin, at bow and stern, and wherever else desired. A magnetic compass, so sensitive to magnetic metals, must be isolated on the bridge in the most exposed position to battle damage. In fact, it is now the practice of our Navy to install the magnetic compass in the crow's nest, high up in the foremast, with a repeater dial on the bridge. Navy ships still carry magnetic compasses in case of battle damage to the gyrocompass. A gyrocompass cost so much, however, that only passenger liners and larger warships commonly were so equipped until the Nazis loosed their magnetic mines in 1941. These were pulled into passing ships by the magnetic attraction of the ship's steel plates and machinery. The British found a quick answer. This degaussing belt, which reversed a ship's magnetic field, defeated the magnetic mine, but it also destroyed the already wobbly accuracy of magnetic compasses. Every deep-water ship now needed a gyrocompass. This sudden demand coincided with our enormous shipbuilding program, hence a quick necessity for gyrocompasses in numbers undreamed of until now for old ships and new. There were only two sources, Sperry and the Arma Engineering Corporation, both neighbors of the Brooklyn Navy Yard. Neither was set up for mass production. The Navy first planned to expand these plants, but after Pearl Harbor, a vision of one blockbuster bomb knocking out the Yard, Sperry, Arma, and the Brooklyn and Manhattan bridges sent the Navy looking for a new source far removed. After a countrywide survey, it chose Detroit and Chrysler, proposing that the corporation take over from Sperry, the manufacturer of the Mark XIV model, in intermediate size. When Captain Hughes and Commander Hall walked into President Keller's office that February day of 1942, Mr. Keller had no knowledge of their errand. When he had heard it, he thought a moment. All plants were loaded up by then with war jobs, Dodge as much as any. But Dodge was a plant into which one more job might be squeezed. He phoned the office of Fred Lamborn, vice president of the Dodge division in charge of manufacturing, asking that some key men be sent over to talk about a new job. The two Navy officers had brought along a prospectus containing a description of the compass, but without drawings. It told a mechanic little of what he would want to know. Mr. Keller handed the book to one of Lamborn's men, A.B. Kirsch. Kirsch is an exquisite mechanic who had worked in the Dodge toolroom since 1914, the kind of craftsman not interested in a job unless it challenges his ingenuity. He glanced at the frontispiece and commented, "Oh, a Sperry Gyrocompass," with which he described the insides of the instrument more usefully than did the book. "Can we make them?" the president asked the Dodge delegation. "Why not?" they said. "We ought to get a sample compass, though, and first have a good look at it." Captain Hughes said he would gladly borrow a compass from the Brooklyn Navy Yard. Mr. Keller buzzed for a secretary, told him to get the Navy Yard on the phone for Hughes. "Ask them," he told the captain, "to load it on tonight's Detroiter. We want it here in the morning." "But it weighs more than half a ton," Hughes exclaimed. "If you want action, having it here in the morning is more important than the cost of getting it here then," was the answer. The call came through. After Hughes had hung up, Commander Hall had an afterthought, exclaiming, "We should have thought to ask them to send along an expert to disassemble the compass for Dodge." "Somebody put it together," spoke up Kirsch. "I guess we can take it apart." This was a Thursday. Before Monday morning, the sample compass was broken down into its individual pieces and subassemblies for the study of Dodge master mechanics. By the following Thursday, Mr. Keller led a group of Dodge men to Brooklyn to make sure that the Sperry drawings and specifications were in condition to permit immediate manufacture. In the group were Lamborn, Dick Knight, who was to become superintendent of the gyro shop, Art Sachet, the electrical engineer assigned to the contract, and Kirsch, appointed master mechanic. Back in Detroit the next morning, 8 days after Hughes's and Hall's visit, Mr. Keller wired the corporation's acceptance of the assignment to make 1,000 Mark XIV compasses. A letter of intent came from the Navy on March 23rd in advance of a formal contract. The Navy does not tell one contractor what it pays another. Lacking all cost information, the corporation accepted an estimated price of $7,500 a compass on the Navy's assurance that this was a fair figure. This was a cost and fixed fee contract. Cost plus contracts became notorious in World War I, the contractor being paid a percentage of his costs. The greater the cost, the greater his profit became. By the cost and fixed fee method of World War II, the government and the contractor agree in advance on an estimated cost. The contractor is paid a fixed fee. Whether the actual cost is found to be lower or higher, his fee is supposed to be unchanged. His costs are, of course, scrutinized and approved by the government before he gets his money. His profits are subject to final renegotiation if the government thinks they are excessive. The cost and fixed fee contract is suspect in Congress. Its critics say that it does not protect the government sufficiently, that it encourages a sloppy job by neither rewarding savings nor penalizing waste. A very close approximation of costs on this contract now is available. Though the first several hundred compasses cost well more than the estimated $7,500, the corporation lowered the cost so continuously that the average cost, excluding spare parts, was about $4,098. Including spare parts, it was about $4,269. This figure would have been lower still, but for engineering and equipment changes made from time to time at Navy direction, and had the Navy's need warranted production and capacity. No part of these savings went into Chrysler's pocket. Its compensation was governed by the estimated costs. These were lowered on the second contract and successively as the corporation perfected its manufacturing methods. The corporation's fee would have been $2,573,105 on the basis of the originally estimated cost. Actually, Chrysler was paid $2,009,242, a saving of $563,863 in the government's favor. This, added to $19,210,000 reductions from the originally estimated manufacturing costs, makes a total savings of nearly $20 million to the taxpayers. Much of the manufacturing equipment was rented from the government at a cost to Chrysler of $391,000. It cost $1,037,000 to tool up for the first 1,000 units at a production rate of 4 a day. It cost only $163,000 for the added facilities with which to double production to 8 daily. When the Navy asked Dodge for 12 daily, the further facilities cost a mere $60,000, a striking example of the economies of engineered production methods. The first Compass was accepted by the Navy on September 11, 1942, and shipped direct to Benton Harbor, Michigan, for installation on a new minesweeper. It had first been assembled 6 weeks earlier, registering the outrageous error of 28.2 degrees, or enough to deflect a ship sailing for Liverpool to the bulge of Africa. Dodge men repeatedly took it apart and put it together again, checking every detail with blueprints and specifications without reducing the error, let alone correcting it. The Navy's resident inspectors tried their hands with no better luck. By a process of elimination, the error was traced to the Mercury ballistic, yet every dimension here was closer than the Sperry print dictated or the Navy enforced. When the ballistic was removed, however, and that of the Sperry sample substituted, the number 1 compass quickly settled out to within 2 degrees of north. There is a breather in the ballistic to allow the escape of air as the mercury flows back and forth. In the breather is a strand of wool intended to keep dust out. The specification called merely for a 6-inch strand of white wool yarn. There was no mention of weight or twist. When the wicking bought by Chrysler under these specifications was compared, it was found to be markedly different from the loosely twisted wicking of the Sperry sample compass. The denser wick was interfering with the escape of air and so slowing the compensating flow of the mercury. The bug was in the seemingly least important detail of a precision instrument, a bit of wool. With a strand of ordinary knitting yarn bought in the nearest 5 and 10, the first compass settled out to an error of 0.1 degrees, or substantial perfection. As with all war contracts, there was an unceasing battle for machines, tools, and materials, and the inevitable agonizing disappointments. But on the day before Christmas of 1942, the gyro shop delivered its 100th unit as a stocking present for the Navy. The 200th compass set out for sea on January 18, 1943. In that month, Dodge shipped 160 compasses against a Navy rated capacity of 100 on its machinery. The Navy now was asking Dodge to move up from 4 to 8 a day, and in March, Dodge shipped 215 units, better than this doubled rate. In the last days of 1943, the Bureau of Ships asked the corporation to go to 12 a day, authorizing the additional machinery and equipment. The production rate was reached in the first week of April 1944. It was not continued only because the Navy, meanwhile, had found that supply had overtaken demand. The theory of the compass has been described. This theory can be translated into effect only if the mechanism is in exquisitely exact balance, and such balance is possible only by micrometric accuracy in every detail. Of the 10,000 parts of a Mark 14 compass, the cases are the only metal not machined to microaccuracy, some parts to 1/10,000th of an inch, or about 1/50th the thickness of human hair. When the 50-pound bronze rotor is spinning at 6,000 revolutions a minute, it must be with so little vibration that a dime can be balanced edgewise on the case. Until the rotor is in perfect balance, every disproportion is registered on a screen by the rapidly moving finger of an electronic device called a cathode ray oscillograph. It not only reported the condition, but points out the location. The rotor is suspended by a strand of 18 fine wires, each 9 1/1000ths in diameter and identical in length and tension. Examined under a microscope, they must form a perfect circle with a hair-size open space down the center. This precise weight and balance is one of the many critical details of the compass. The master compass being located within the ship, and the rotor being hermetically sealed in an aluminum case, the binnacle or outer casing is merely a housing. But the cases of the repeater compasses, which also seem to the lay eye to be mere jackets of no functional consequence, are exhausted in a vacuum. Then, in order to fill their bronze pores, they are impregnated with an impervious lacquer under 30 pounds pressure and baked at a high temperature for 2.5 hours. They must be both water and airproof. Exposed on deck, the repeaters may be submerged by waves, while air produces moisture under condensation. A basic reason for Dodge's success with this strange and delicate instrument was the Chrysler tradition of unit testing of subassemblies before final assembly. For example, Dodge makes the transmissions for all Chrysler cars in normal times. Each set of gears is tested for noise and runout before they are assembled into a transmission. When subassemblies are checked carefully, errors are caught and corrected before final assembly, with marked savings of time and money. From the final assembly line, the gyro compass passed into a test room which included swings essentially no different from a lawn or a porch swing, where it rocked as placidly as a summer border, while inspectors checked and adjusted it at frequent intervals, noting its symptoms on a fever chart attached to the swing. From simple swinging, it graduated to Scoresby machines, which counterfeit the roll, pitch, and yaw of a ship laboring in heavy weather. Counterfeit so successfully, the inspectors, surrounded by a bobbling ballet of these machines, were known to grow seasick from following the gyrations with their eyes. A compass, which continued to register true north after 20 hours of this torture, was ready for sea. Sperry specifications allowed an error of 0.5 degrees, plus or minus, in the swing test. Dodge held this to 0.3 degrees. On the Scoresby test, where the Navy allowed a deviation of 0.6 degrees, Dodge tested to 0.3 degrees. One faulty compass, which defied diagnosis for many days, was found at last to have a fleck of paint on one bearing. That was all, but on a bearing true to 1/10,000th of an inch, it was enough to disable the entire assembly. These bearings were inspected and guarded in an air-conditioned room, like so many incubator babies. The 5,500th compass did not leave the Dodge plant until early March, by when the gyro shop machinery had been dismantled, and the working force scattered on other war work. It was waiting for a special nameplate which celebrates Dodge dependability. As a grateful gesture to the Chrysler Corporation, the Navy has assigned this final compass to a 14,000-ton ship not yet completed in the Philadelphia Navy Yard. This vessel has become the flagship of the Combined Chiefs of Staff of the Amphibious Command of one of our joint Army-Navy groups in the Pacific. The making of gyrocompasses was a semi-secret handicraft in 1942 when the Navy turned to the Chrysler Corporation. That means hand skills, guarded trade secrets, small quantities, and slow output with a necessarily high cost. Small quantities do not permit the high tooling costs of engineered production, which produce an automatic accuracy and high output. Different jobs are asked of one machine and one operator, with time-wasting shifting of fixtures. There is no absolute uniformity, and therefore no certain interchangeability of parts, for the finest craftsman cannot make two identical things. It takes a machine to do this. Hence, hours of filing and tailoring are necessary in assembly for exact fit. There was a time when precision could not be had any other way, when mass production was limited to coarser things. Chrysler has changed this. The corporation made this intricate and delicate instrument to an accuracy beyond that of handcraft, in any quantity and at any speed the Navy asked for, and at great savings. It did this by applying its technique of engineered production, just as it has done with all its war jobs. Production broke the product down into its simplest components. Tool designers contrived machines and fixtures which left nothing to the judgment and initiative of the operator, transferring the accuracy from the man to the machine. Master mechanics and planning laid out the machinery for the smooth, never-interrupted flow of parts to subassemblies, subassemblies to final assembly. Each part became micrometrically identical with another of its kind. Final assembly was not interrupted. Chrysler purchasing agents bought the materials and purchased parts to best advantage. Chrysler inspectors checked the quality of these materials. Chrysler supervision, watching all, prevented waste. The high cost of the tooling was recovered many times by the reduction in man-hours. From all this, the savings of nearly $20 million of your tax monies followed almost as automatically as the precision of any gyrocompass part. That concludes A War Job Thought Impossible.